If you are an electronic hobbyist, chances are you like high voltage. Those arcs are really beautiful, colorful, and it is really fun to play with them. But what is the voltage of your high voltage setup? You can try to measure the distance at which the arc strikes and multiply that distance by the air breakdown voltage. But in this way you're gonna have a misleading answer, because the breakdown voltage depends on many factors and is not constant. Into this project we're gonna see how to transform this cheap analog multimeter into a 25 kilovolt voltmeter. But first we need to understand how an analog voltmeter works. In simple words, it is a copper coil wrapped around the base of the needle and in between of two magnets. The movement of the needle is proportional to the current that flows through the coil. Bigger the current, bigger the movement of the needle. Now, how does this thing measure the voltage? For a certain current through the coil, we have a full deflection of the needle. But how much is this current? We can find it looking to the meter. Here is written that we have 2 kilo ohms for every volt DC. Using Ohm's law, we calculate that the current is 0.5 milliamps or 500 microamps. This is the current that moves the needle full range. And it's not by chance that this is the lowest current that the meter can measure. Now imagine that we add a resistor in series with the coil. What do you think? How much is the needle gonna move if we connect this to a voltage source? Now, the current that flows through the coil depends on the resistor. Let's use again Ohm's law. Voltage equals current multiplied by resistance. Now, a current of 500 microamps is gonna move the needle full scale. Let's suppose the resistance is 100 kilo ohms. This means that the voltage that causes 500 microamps to flow through 100 kilo ohms is 50 volts. So 50 volts would make the meter go full scale. Now, suppose that R is 1 mega ohm. This means we can measure now 500 volts. What if we want to measure a much higher voltage? For example, we want to measure 25 kilovolts. What is the value of R? It's the same thing. We use again Ohm's law. We want to know across what resistance 25 kilovolts are able to move 500 microamps of current. If R is 50 megaohms, 25 kiloohms across the meter are going to move the needle full range. Here I have connected many high-value resistors in series. Now let's measure the total resistance. It's almost 50 megaohms. If you are 50 point something, it's completely okay. Now we need to connect the resistance in series with the meter's probe. And we have to measure the voltage across these 2 points, the resistor and the probe. A full movement indicates 25 kilovolts, so we can use 250 volts division. But we have to multiply the readings by 100. And don't forget to set the meter in the 0.5 milliamps position. Now let's measure something. The meter tells us that the voltage is 5000 volts. Here it is. Watch carefully. When the arc strikes, the voltage goes down and the current in the arc goes up. Now let's measure the air breakdown voltage. The arc strikes when the electrodes are 5 mm apart. This means a breakdown voltage of 10 kV per centimeter. Now let's increase the voltage to about 10 kV. Now the arc strikes far apart and it is much longer and much hotter. And as always, thanks for watching. Please consider subscribing, and if you really like this project, share it with your friends.